This is another problem from Module 10 on the depression of the freezing point temperature. And so the problem reads, if you want to lower water's freezing point 18 degrees Celsius by adding sodium chloride, what must be the molality of the salt solution? And remember the constant for water, the freezing point depression constant, Kf, is 1.86 Celsius per molality. So already when it's talking about the freezing point and lowering that freezing point, we know we are going to use the equation delta T, or change in temperature, equals negative I times Kf times M, where I represents the number of molecules or ions that the solute dissolves into, it splits into. The Kf is the temperature depression, freezing temperature depression constant for the solvent. Molality is the concentration of the sodium chloride solution. So we know we're going to use this equation, but often what variables we are given in the problem are not always in a form that can be used in this equation. So we have to remember things that we have learned before. So what do we know from here? Okay, if we want to lower water's freezing point 18 degrees Celsius, this already tells us that the temperature needs to change 18 degrees Celsius. That means this number represents delta T, and because we know we're lowering it, it's got to be negative. So our delta T equals negative 18 degrees Celsius. The freezing point depression constant is given to us in the problem as 1.86 degrees Celsius per molality, and this is for water. And what they want to know is what is the molality, or the concentration, of the sodium chloride solution. So that's what we're looking for here. And as far as the I, okay, we have to take a look at our solute, which is sodium chloride. It's going to split when it's dissolved into water into sodium ions and chloride ions. So that I value is going to be 2. And so we know delta T, we know I, we know Kf, we just simply don't know M. So to begin with, we just simply write in our equation what is known. We know that delta T is negative 18 degrees Celsius. We know our I value is 2, and we keep the negative sign because it is part of the equation up here. Our constant is 1.86. And molality, we could have actually even used just an X here. This is our unknown. And so all this is just simply an algebraic equation, right? So here's our unknown. We have to isolate M, which means we need to divide both sides by this product. And whether you multiply it now or later is irrelevant, right? But if we were to change it before we did that, right, we divide both sides by 2 times 1.86, that would leave, since we're dividing by the same number, that will leave M alone on this right-hand side. And we would be left with, on the left side, negative 18 degrees Celsius divided by the product of negative 2 times 1.86 degrees Celsius per molality. And we know that those degrees Celsius will cancel, and molality will then be, because this is 1 over, if you remember your algebra, which I'm not going to go into right now, but this will become in the numerator. And if we were to do that math calculation, we come up with a number such as 4.8387 molality solution of sodium chloride. However, if we look at our equation up here, we only have 2 significant figures in our temperature change. So we know that our answer can only have 2 significant figures. So we want to keep the 4 and the 8, but we have to look at this 3 to the right of the 8 to know what we want to do with that 8. And since that 3 is less than 5, we are going to keep that 8 the same. And so we have a 4.8 molar solution of sodium chloride that needs to be added to water in order to depress the freezing point from 0 degrees Celsius to negative 18 degrees Celsius. And so this is our final answer.